In this program, we will show that the discrete time sinusoids are not always periodic, unlike the continuous time sinusoids, which are always periodic. The reason behind this is that since the time period n of in case of discrete time sinusoid must be an integer number. Okay, this was not the requirement. This is not the requirement for the continuous time sinusoids. Okay, now this requirement on the time period n is the it reflects in frequency domain as the frequency f must be an rational number. Okay, so if the frequency f is a rational number, then only the discrete time sinusoid will be periodic. Otherwise, it will be an aperiodic signal. Okay, so to verify this, I have written a code here. So we can see that I have taken n from -15 to +15, and I have defined three frequencies here. Okay, first one is f1 equal to 1 by 5. So you can see that this is a rational number, and the second one f2 equal to 1 over 1.7 pi. Okay, you can check that this is an irrational number. Okay, then f3 as 1 over 1.8 1.8, it is again a rational number. Okay, then I have defined this function x equal to this sign at the rate f. Okay, this means our variable will be capital F, and the function definition is cos 2 pi f of n. So we can call this function f by these different values of f. Okay, so I have defined the first signal x1 equal to x of f1, means I am calling this function for the value of this frequency f1 equal to 1 over 5. Okay, so since this frequency is rational, so this signal x1 must be periodic. Okay, so the time period will be, we can calculate it as n over m by f, where m is an integer such that n is an integer. Okay, so you can calculate that here the time period will be n equal to 5. Okay, similarly x2 equal to x of f2, means uh, in case when this frequency f will be equal to f2, then this signal x of 2 will be aperiodic, because since in this case f2 is not a rational number, right? Okay, so you cannot find any number n after which the signal will be repeated. Okay, that's why it is an aperiodic. And in the third case, the frequency f3 is again a rational number, so this must be a periodic, and its time period will be n equal to 9, as we are going to see in the plot soon. Okay, now these commands are to just plot this x1, x2 and x3. Okay, so let us plot this, run the program, and here is the output of the program. Okay, so here you can see this is the plot of x1, then this is the plot of x2, and the third plot is of x3n. So you can see that this plot or this signal, when the frequency is rational, so we have calculated that n is equal to 5, means this time period of this signal is 5 samples. Okay, so let us check that this is the n equal to 0th value. Okay, then this is n equal to 1, n equal to 2, n equal to 3, and n equal to 4, and for n equal to 5 this value is repeating. Okay, and similarly for n equal to 10, n equal to -5, and n equal to -10, and so on. So clearly this signal is periodic with n equal to 5 samples. Okay, but in this second case, you cannot find any integer value n such that this signal is repeating. You can check that there is no uh, definite pattern of this. For example, at 0 this value is 1, but this you cannot find the same value after an integer period. Okay, so this is an aperiodic signal. Okay, there is no such pattern here again. Okay, so this is a clearly aperiodic signal. Okay, so this verifies that the discrete time sinusoids are not always periodic. uh, the third one, this signal is periodic with n equal to 9. You can check that at 0 this is 1, and after n equal to 1, 2 and so on, when you will go to n equal to 9, this value is repeating. Okay, and similarly here for n equal to -9. So in this case we have plotted three discrete time sinusoids for different frequencies. In first and third case the frequency was rational, and in second case the frequency was irrational. Okay, so first plot and the third plot are periodic, but this second sequence is aperiodic. Okay, so and we have generated those plots using this code. Okay, so here we stop.